Hello, this is Dan Humberg, harvestfires.com. This is a instructional video that I'm going to make to show you how to mount the fan and filter system for a FireStop Kit. I'm currently on a CaseIH 230 combine, and I'm going to show you how to mount these few pieces here. I'm going to do it probably rather quickly because it's raining here, as it seems to always rain now in Brookings. So let's look at how to put these pieces on. There are two black filter or bracket pieces that are going to mount this on the back right hand corner of the combine on the rail system. I have taken off the fire extinguisher off this one. It sits on the rail on the side here. I'll put it back on because I'm on a dealer lot and they're just letting me use this machine to demonstrate this. But you would probably want to take that off and move it to another spot on the combine because it gets in the way here. This first bracket is this large piece. It will support the air filter that we're going to use here. The bracket sits on 4 tabs on top of the rails, both bottom and top here. And there are, in your kit, there will be 4 U-bolts that will go around those rails and up through the tabs. And if we look down here, you can see I put those, whatever you call those plate washers that come with the U-bolts on top, and run nuts down on the U-bolts and pull them up snug. Now I've just barely tightened this because I'm going to take it back off. I also will send with that, there's one rubber piece in the kit where I trim a piece off of one of the rubber hump connectors. I'll include that piece of rubber, and if you wanted to cushion this at all, you could cut that piece up and put a tab of that rubber inside underneath this tab on top of the rail, and it will keep it from taking the paint off your rail and give it a little bit of a cushion if you want it to do that. That's up to you, but I'll include that piece if you want to do that. So I mount that piece first on here, put the 4 U-bolts in. You don't necessarily have to tighten them up just yet because we may want to shift things just a hair, but just set her in place here. Notice it straddles this corner rail back here and on both top and bottom, but that's pretty easy, straightforward to put on there. The next piece I would suggest you might want to put this second black bracket piece on. It's an L-shaped piece, has a curved cutout here for the fan, and it has 4 bolts that bolt it to the side of this first bracket. It's probably easiest to handle that piece by itself rather than bolting it to the fan itself, and put that on first. There's only one way that it'll line up on here, and it'll give you this half moon cutout here to go around the entry point into the fan. I've put the fan on here already with 3 bolts. They tap right into the housing, and so those holes should be tapped, and there's some adjustment in the fan position here that will allow you to point the outlet where you want it. Once you have this one put on, you can bring those up probably tight to put these two together, and then I would mount the fan on here. You might want a helper and a step ladder or ladder outside here. Bring the fan up, line up these holes, and put 3 8mm bolts or 13mm heads on them. So put those 3 bolts in there. You don't necessarily want to make that tight yet because you may want to rotate this to adjust the direction of the outlet of the fan. But you can put those 3 on there and bring them up closer, snug, so that that piece is in place. Now I'm using half of the clam shell of the fan right now just because it's a lot lighter for me to handle up here, and I'm just doing this demo. So I've split the fan in half and put it on here, and that's only about probably 5 pounds of aluminum. When you have the other half and the hydraulic motor on there, it's probably 40 pounds or more of stuff to hold up or get in place there. So anyway, we got that on. I'll come back in a minute and we'll look at how to put the filter on itself. Okay, we put the bracket in place down here. We hung the bracket on the rails, that large bracket first. It sits right on top of the rails, straddles this corner rail, and there are 4 U-bolts that go up from around the bottom of the rail through those little zinc flat plate washer things, and then you put your nuts on there. The next bracket we put on is this Z-shaped thing or zigzag thing. It has 4 bolts that will hold it onto the main bracket underneath here, and it'll bring it up this side up to where we can hook onto the fan housing. Once you have that bolted onto the side of this one, you can slip the fan up inside that semicircular cutout, and there are 3 bolts that we can thread directly into the fan housing, and I would leave those loose for now because you're going to want to rotate that in a little while, but bring them up so that it holds that fan housing in place. The next step is to mount the filter bands, and probably do this down on the ground or on the bench. Put these filter bands around the filter itself, one on the front end of it, or the outlet end of it up here, and one around the back about halfway between the intake and the duct bill here. Put them on there, leave them loose for now, but have them captured inside those filter bands. The other thing you do is put the rubber hump connector on this end of the filter. It has a 5-inch on one end, and it has a cutout here to go around this sensor port on the filter. You have to pop it over that, and it fits around that, and some little gussets here. Put your band clamp on before you slip it over there, or you'll have to take the band clamp apart. It's easier to slip it on and slip it over the end of the filter. Then you put your 6-inch band clamp on the outer end of it here, and slip, and the whole works is ready to go onto the fan. Now you can bring that assembly, filter clamps or mounting bands, and the rubber hump connector with its 2 band clamps. Then you can bring that up here, and it should slip through here and slip right onto the fan flange, the flange that sticks out of the fan. Slip over that, and then while that end is sitting on there, you can jimmy these filter band bases around in place to where they line up with holes on the bottom, or on this, in this large bracket. There's actually 3 sets of holes, one here, and one here. I like the outer one here, and then of course the front one here, both top and bottom. And so you can fit a 8mm bolt down through there and spin a nut on there. Those nuts are serrated nuts, and so they'll flange nuts, and so you don't need washers there. I just put 2 on now for now because I'm just hanging it here temporarily, but you can put all 4 of those on there. Again, I wouldn't make them tight just yet. I have the filter can pointed out sideways here because it's raining or spitting rain a little bit, and I don't want rain getting inside this filter. But eventually we would rotate this back inside the filter, those bands, those mounting bands, to where the intake is pointed just up inside the rail here. I've put this adapter, it's a rubber hump connector on the intake for the filter. It's a 6-to-5 rubber hump connector with a 5-to-4 insert inside it. We'll rotate this up so she's just inside the rail here, and then we'll have a piece of 4-inch aluminum tube that will come out of there and stick up above the system here, and I've got a top spin intake that'll slip over that and band clamp onto the top of the intake. So that's your air intake to the system. We'll give you a certain amount of that aluminum tubing to get up here. You can always go higher than that if you wish to take in cleaner air if you find that your filter gets full of dust with that intake too low. But if you get too high, you don't want to go probably above your grain tank extensions, or you'll risk wiping that off if you go under something. With the fan and the filter mounted, then we can go into, or at least look at how the hydraulic system gets connected up to the hydraulic motor that runs the blower. I'm now under the left side of the shield of an 8230 case combine, looking up at the maze of hydraulic lines and connections. The hydraulic connections are pretty much common to all of the case combines that I've done, the 8010 all the way up through a 9240. I think a 7120 and 7230, and those would be similar, or the same setup. If we look up here, I'm going to point the camera there, hope we can see that. Well, there's actually a triple pump stack there. It's 3 pumps connected together in series. First one in there looks like maybe that's a piston pump, but I think it's probably a gear pump also. Then the second one and the third one are both gear pumps. The circuit that we're going to tap to operate the blower on this FireStop kit utilizes the flow from the chaff spreader. That's the center pump, or the middle pump in that triple pump stack. There's a very large line that comes from the reservoir and just arcs over here and comes right into that center pump. And then there's a hard steel line on the other side, and that's the outlet of that pump. if we follow that hard steel line down, it's the inner one here. Now the inner one here that I'm looking at, it comes through these grommets, makes a 90 through here, and then back in here makes a 90 down on top of that gold anodized aluminum manifold block. That manifold block is where the speed control of your chaff spreader takes place. There's a proportional valve. The solenoid valve in there is a proportional valve that allows you to dial in the flow rate and get the speed you want on your chaff spreader circuit. What the FireStop kit does is borrows the flow from this circuit before it gets to any use on the combine. Before it gets to this manifold block, we'll interrupt that flow and take that flow, go up to our blower motor, run through the blower motor, and then come directly back down here with that flow for the rest, so that the circuit can utilize that flow for the rest of the functions that it needs to. There's actually two ways that you can tap that. The way that we've done it on most combines, and you certainly can do it this way, is to actually disconnect this hard line right here. It makes a 90 and comes down into the back part of that manifold block. You can just disconnect there, but you'll have to lift that hard line up and bend it or flex it forward or backward so that you can connect onto that line with our flexible hose. It can be done. There's nothing there that prevents you from moving that line, generally probably to the rear a little bit, in order to hook on the FireStop hose end. The hose that you'll get is a number 12 or 3/4 inch hose, and it will have a 90-degree fitting on the end of it, and so we can put our 90 onto the end of this one here. In actuality, these connections are flat face O-ring seal connections. They have both the male and the female ends have a flat steel face on them, but the one that we would call the male end has an O-ring, a rubber O-ring cut into a groove in the face. And that seal, the seal for that type of fitting, comes at the O-ring. It does not come from crushing metal on metal. It actually comes from the appropriate squish of the O-ring, and that doesn't take a whole lot of torque. So don't go nutso when you're, or gorilla or whatever you want to call it, when you tighten these up. You'll feel it come up abruptly when the steel faces meet, and it only takes a modest amount of torque then to crush the O-ring and keep the rest of it tightly together. But anyway, this is the steel line. If you take it off here, is going to be what I'd call the female part of that connection, and then we need a male to go into it. So the hose that we get is also female on the end. The fitting that we order with our hose section is female, so we need a male to male fitting, which is provided in the kit, to make that connection if you choose to do it that way. So you would disconnect right there with a wrench. It seems to me, if I recall, it's something like a 34 millimeter wrench, 34 or 35 millimeter wrench, to pull that fitting off. Or I've seen people do it with an adjustable wrench, or even like a slip-jawed pliers if you're strong enough to get that in there and disconnect it. It doesn't take a lot. Once it snaps loose, it's pretty easy to get that taken off, but breaking it loose may be a little bit of a challenge. But you back that one off, twist that line towards the rear of the combine a little bit, and then you put on the 90, or put on the male-to-male connector on the end of our 90-degree fitting on the hose, and point that up into that line and connect onto it, and then that would be your supply to go up to the blower motor. The return line from the blower motor also has a female flat-faced O-ring 90 on it, and that one will go back onto the stub sticking out of the manifold block here, where we took this hard line off, and simply return the flow back into the manifold block after we've used it to run our fan. And that's one way of making the connections for the hydraulics to run that blower. The second option, and I've had at least one farmer choose to do this, is to actually interrupt or disconnect the hard line up there right where it comes out of the second pump, the middle pump. And that's also a flat-faced O-ring seal connection, and that farmer simply took this entire hard steel line, took that out, and you can do it. You can disconnect it down here disconnect it up at the pump, hook a hose on, hook one of our lines, the supply line, to the motor up at the pump, and go directly to the motor then with that supply line, and then the return rubber hose comes down and connects onto the where this hard line is on top of the manifold block. Then to do that, you actually remove this hard line. There are two retaining grommets, I think, here, or maybe it's only one on this one. No, there's two. There's that big one right there, and then this one down here that you have to loosen up in order to take that line out. But it's actually not terribly difficult to snake that line out. And then you're going with our flexible rubber line directly up to the motor from the pump, and the return line comes back down and hooks onto this manifold block. It's actually a little bit cleaner installation that way. I would, if I were you, I'd hang on to this steel line and close up the ends and keep something over them tight so that you don't get dirt in there, because either you may want to put that back on eventually, or if you trade machines or whatever and want to resupply, want to keep the FireStop kit, you may end up putting that line back on. But that's up to you. You can hook on down here and go up and come back down and hook onto the manifold block with the return, or you can go from the middle pump, the same pump as the steel line comes from up here, and hook onto the pump. And then you don't need the male-to-male connector, because you have a male fitting coming out of the manifold block here, and you have a male fitting coming out of the pump up there, and both of our hose ends have female fittings on them, flat face O-ring seal fittings. So that's why how we supply to the fan motor, and bring the return back down in here and go into the manifold block. Now we're sending nearly all of the same flow back down here. We have a case drain on our motor to protect the seal, and that's absolutely necessary on that one. And so there's a very small flow that comes out that case drain, and that little bit of flow isn't then available to this circuit. Generally, you're probably not using every bit of flow in this circuit, because you generally probably have your chaff spreader at something less than the absolute maximum speed, and so you've got plenty of flow to do that. Now, I also had one producer on a 9240 elect to hook on back here where this line leaves the manifold block up here and comes down to supply the flow to the chaff spreaders. And so he would have broken, I think it's right here, the lower one. I'd have to check that for sure, because I want to make sure it's the supply and not the return from the chaff spreaders, although either one would probably work. But he interrupted that flow at this point and hooked our line on here and went up to the blower motor, and then came back down with the return and went back into the remaining fitting here. That's also an option for you. The catch with that one is it's very convenient to reach here, and it's not hard to make the connections. But the caveat that you have to understand is now the flow that's going to the blower motor is the same flow that goes out to the chaff spreaders, and that is sometimes not the full flow that goes into that from that circuit. And so your fan motor may be running at a reduced speed because you're only using part of the flow from that circuit. I've sized the hydraulic motor to get somewhere in the neighborhood of 3,000 to 3,400 RPM on the fan motor, depending upon which combine it is and which pump it is and that kind of thing. But using all of that pump flow, we get that kind of spreader, or that kind of fan speed. If you tap in here and then you dial back the spreader speed, you probably will have a reduced fan speed, and that means you have reduced airflow into the box around your hot components. And so I'll warn you that you need to, if you're going to do that, just be aware of that. And I wouldn't, in flowers, I would run the chaff spreader at maximum speed so that you have pretty much all of the flow in this circuit going through the blower motor before it gets down to the spreaders here. But that's up to you. You can do it that way. In other crops, it probably doesn't matter as much if you reduce the spreader speed and your fan speed slows down, because you probably don't have the fire risk that you do have in sunflowers. And so, but in sunflowers, you would definitely want to keep that fan speed up so that you get the maximum both airflow and pressure inside the box where we enclose the hot components. Okay, so that's how we supply flow up to the motor. Now, I didn't show connections on the motor. Those are pretty straightforward when you get up to the motor itself. Those are JIC flare fittings that go on to both the inlet flow to the motor and the return flow from it. Now when you receive that, there will be a little circuit plumbed from the two sides of the motor, inlet side and return side, and there will be a relief valve across that in a little loop of 1/2-inch hose. I put that in there because if anything ever happens to the fan, let's say the impeller comes loose on the shaft and slides over and jams against the housing, I don't want it to stop that unit, and that would block the flow from the pump to your chaff spreaders. And if that happened and you didn't realize that something had happened like that, it will damage the pump before very long by blocking that flow. And so in this case, if anything happens that makes that motor stop for whatever reason, the flow will bypass around it with a 500 pound per square inch pressure drop. We've set that relief valve at 500 psi, which is fairly modest, but it's more than enough to run the fan, so it won't generally open that to run the blower itself. But if something should happen that it jams, it will bypass around that, and the rest of your circuit will continue to operate. You would not have any airflow at that point if it stopped the fan, but you wouldn't damage the pump, which is much more expensive to replace than any of the other components of my system. So you hook on to the inlet with one JIC flare fitting. Sorry, I'm in a dealer lot next to a highway and I get a lot of truck traffic here. You connect on with the JIC flare fitting to the inlet of the motor, and the return comes out the other side with another JIC flare for the return that comes back down to the manifold block here to go back into the circuit. The JIC flare fittings also have a specified torque. If I remember to, I may post the appropriate torques for those size hoses and types of fittings on the website. If I don't, you can certainly look it up if you Google torque for hydraulic fittings. There will be a table that'll say for which type. But generally for the flare fitting takes a little bit more torque. I recall it's in the neighborhood of my remembrance is that it's somewhere around the 42 foot-pounds area for a number 12 fitting. The flat face O-ring seal fittings take generally less than that in order to seal up tight. You don't want to over torque a flare fitting. You can actually crack the flare fitting and then, or one of the fittings anyway, and damage it, and then it will leak. So you want it to be tight enough but not excessively tight. Okay, so those are the two supply and return connections. There's also the case drain, that's the smaller hose. On the motor, there will be either provided on the end of the hose or on the motor itself. I'll provide you with a 90-degree fitting that comes out of the motor, the small one. That's an O-ring seal. They call it O-ring boss. It's different than the flat face O-ring, but it allows you to spin in that 90, and then there's a little nut at the bottom that you can turn on if you want the 90 pointed one direction, and snug that nut up to crush the O-ring underneath it and seal it. And then after the 90 on that fitting, it's a small flare, again JIC flare, but it's number 8 or I think number 8. Actually, this might be 3/8 inch. It'd be number 6. Anyway, that hose will spin on the end of the crimp fitting on the hose will spin on there and come up tight, and that takes a modest amount of torque to seal that case drain. The other end of the case drain, I'll show you up where we tee that in through a run tee into a number 10 fitting on the top of a hydraulic pump. In fact, we can see that hydraulic pump down here. If I'm looking up at, this is a piston pump in this case, and we're looking at the inlet on this end. The big line is the inlet, the outlet steel line is the outlet, and there's a pressure signal line up there. I think it's maybe a load sensing pump. That's that small line, and then the line with the orange stripe on it that goes to the top of that pump, that's actually the case drain from that pump. That takes the leakage flow from inside the pump that slips past pistons and stuff, and will bring that back to the reservoir. And we're going to tee into the top of that, disconnect that fitting, lift it up and put a tee in there, put the fitting back on, and then bring our case drain line onto the side of that tee through a reduction fitting. Okay, so those are actually the only 3 lines you have to hook up. Once you have them hooked up, you want to make darn sure that you have snugged up every one, that they're all tight, that you haven't left one finger tight somewhere. Oh, and one other thing that I want to point out, when you have when you're ready to connect up at the pump, up at the motor, I say pump and motor. when you're ready to connect up at the blower motor, before you connect up there, you make your connections down at this end, and just before you connect up at the motor, you fill those hydraulic lines with oil. Get some clean hydraulic oil, fresh clean hydraulic oil. Make sure that you have a clean funnel or something. Don't pour it through some dirty can. Hydraulics are like your blood. You do not want crap in your blood, and you don't want dust or dirt or crap in the hydraulic system on the combine. So you take a clean funnel and you pour hydraulic oil into the end of that hose. Give it some time to fill the hose, because it takes a while for it to drain down and fill it. And once you've got that hose filled to the top, then you make the connection at the motor. It'll be a little messy and you'll lose a little bit, but you fill both of those lines up. If you don't do that, you're going to push a great big long, about 20 feet of air back through this manifold block. And there's a hydrostat in that manifold block that helps in the control of the speed of your fans, your chaff spreaders. It doesn't know what to do with all that air. It doesn't function right with it, and so it can handle a little air bubble if you don't get that hose perfectly full. But you don't want to try and push a long bubble of air through there. It'll take an hour for this thing turning it on and off to get it to work right. So fill those hoses up there with oil. You do not need to fill the drain line with oil. That goes back to the reservoir, and the air in that line won't bother anything. So don't bother to fill the small line, but fill the two large lines with oil before you close them up and tighten them up at the fan motor. So those are the three hoses you have to connect. It's actually relatively simple. The only question is whether you choose to take this hard line here off, or whether you choose to leave that in and just move it over here and connect onto the bottom of it with the flex line. That's up to you. Again, you can also tie in back here. It's just then your fan speed is going to be proportional to the spreader speed that you select from the cab. And it will be something less than the full speed that we've designed it to run at. I'm going to point out again, we're now looking down on top of that hydraulic pump. The large line we're looking straight down at in the middle of your picture. Coming out of that pump, the pump is very dirty on top. Please clean your combine off at the end of the season before you put it away. That's a mess. And that has to be cleaned off before we disconnect that case drain line. Or on this one, it would have to be cleaned off, because you don't want to get dirt in that system. The small line there is a pressure sensing line that's used by the pump to know how to set itself. And then this larger line here is the case drain from the pump. And we will, in the case of the case drain from our fan motor, we'll simply loosen the fitting down that's shown, that we're looking straight at right there now. Loosen that one up. As soon as you can take it off, you lift it up quickly high to keep from losing too much oil. Once you get it above the level in the reservoir back here, it won't leak. And then you can hook the T onto that same fitting. And we've got what's called a run T. These are flat face O-ring connections. Again, they connect up quickly and easily and snug up and close up tight. Anyway, you can put that run T on there, and you can actually have the case drain line on the run T and have that one tightened up ahead of time. And then you simply bring either the line down on top of the T, or the line with the T on it back down on top of the motor there, and make that connection as quick as you can, because you're going to start to lose oil as soon as you bring it down. And spin it back on there and snug it up, and then tighten it just enough to make sure that we don't leak going back to the reservoir. Those lines are never under pressure. They're only connected back to the reservoir, so it's only going to take a few pounds per square inch to push the flow through there back to the reservoir. But they still need to be sealed. You just don't need. They're not going to be subjected to thousands of pounds per square inch. So that's where the case drain will hook up. You can route the hoses however you choose to on the machine. Most guys are going to bring them up across the floor here and follow kind of the base, that curb there on the base of the engine platform or the service platform, and go underneath here by the air filter, and then out under the rail over here, and bring them up to the bottom of the fan motor. And they'll bundle fairly well that way, and they're appropriate lengths for that. So you want to do that. You do want to make sure that you don't have them in a position where the edge of the hose is going to rub against a sharp edge on a piece of cut steel or whatever. If there's any question about that, tie them, use some big zip ties or something and bundle them and tie them so that they're not, don't have hard contact with a vibrating edge, because you don't want to cut through those hoses. Alright, we're back up on top of the platform of the 8230 on the lot here. I've actually taken off my blower and filter and stuff here, but those would be mounted in this corner of the platform on an 8230, and we'll actually use the exact same mounting method for all of the case combines except the 8010. The 8010, that's where your ladder comes up, and we have to go over to the other side over here, which has different railings, and we can hang the same fittings on there, but they have to hang a little bit differently. But if we had the fan and the filter and the blower on here, the blower's outlet would be looking up kind of somewhere in this direction, from the outside of the rail, depending on how you choose to rotate it or to angle it. You can do it anything from down level or low here, up to rotate it up to an angle up here. Most producers where we put out these kits on have chosen to route the air line from the outlet of the fan up inside this railing. It'll come from outside here and shoot up inside this railing, and we make a 90-degree turn with a rubber elbow right up about where my finger is here, and come to the left across the top of the air intake for your engine air, and pass across the back of the combine here to this area where we can dive down here. Actually, we can make a 90-degree turn here. You could either go down with a 45 and then a 90 in, but mostly what we've done is come across here, put a 90-degree fitting on, angle that 90 degrees down a little, like 45 degrees, to get down into this gap underneath the bonnet or the hood here, and then we put a 45 on right after that 90, and that directs us straight underneath across the top of the valve cover. I don't know if I've got enough light so that you can see that here, but we can shoot underneath here and go right over the top of the valve cover and go one side or the other of the yellow fill cap for your oil fill, and probably over the top of that coolant line or whatever that line is there, and then a 90-degree rubber fitting to turn down, and that's where we would connect on to the galvanized HVAC fitting that is connected through a stub connection into your galvanized box around the exhaust turbine. So we've got I will supply pieces, rubber fittings, and aluminum tubing for that kind of routing on most of the case combines. This is the routing on an 8010. Take that back. 8010 is different than this. 8120. The early 8120s and the later 8120s both have this same kind of a configuration. They have a little more room maybe than the 8230 does here, but same kind of orientation works for the routing of the air. 8230 and 9230 and 9120 all can use the same arrangement, and I can supply the aluminum pieces cut. It takes about 22 inches to go here, about 47 inches to go across here, a short stub to connect the 45 on here, and then I think it's 37 inches to get over the valve cover. So I'll cut those ahead of time and ship them that way with the kit, unless you tell me differently, unless you say I want to route the stuff differently myself, and then I can send you up to 7-foot long pieces of that 4-inch aluminum tubing and you could choose to cut those to route the line the way that you wish to. But this is the way that seems to make sense for a number of these case combines, is to get it from the blower into the box over the top of the engine that way. Now if you're running an 8240 or a 9240 or an 8250 or a 9250, then they added on some stuff right back here, and it's a little bit different. You can still route the lines that way, come up from the blower, come across here, but generally you end up, it's harder to, you can't go, there's not a nice cutout here where you can't go in there. I don't have one right close by to look at, or I'd show you. I have had people with a 9240 actually go in over the top step here and shoot over the valve cover that way by going over the top step with the line. Otherwise it came across kind of the same way, but we may want to look at alternate routes for the airlines on the 8240 and 9240 and the 50 series. 50 series is the same as the 40 series in terms of exhaust, I think. So I'm guessing the rest of this will also be about the same. But for anything below an 8240 or 9240, this is the way that I would typically connect those pieces up, and I'll supply rubber fittings to do that connection. A 90 over there, a 90 here, a 45 here, and a 90 to go down over the valve cover. Well, that's all that I can think of to talk about the connection system on here. We've talked through how to mount the fan and the filter, how to connect up the air lines from there to the, as far as the our box around the exhaust manifold and turbocharger, and how to hook up the hydraulic hoses. Again, you can go either from the pump itself, or you can tie or cut in down at the manifold block for your spreaders. So if you have questions, if there's something not clear about this and you want to give me a call or ask or post a question to me on the web or the email connection at harvestfires.com. It's harvestfires@outlook.com is the email. You can send a question or an inquiry there, and I'll try and answer your questions. Thanks very much. Please be careful with as you harvest. While I'm here, I want to point out one other thing. Okay, I am looking down underneath the unloading auger, right ahead of the giant muffler thing, that's giant muffler shaped like thing. On the combine, and you'll notice that there's a large hydraulic hose coming out of the, actually it's covered with dirt. This machine didn't get cleaned off last fall, and it's a dirty pig. I recommend you clean the machine off at the end of the season. Anyway, that looks like a number 12 line, and it is the case drain from the pump that it's hooked into there. It takes the leakage flow that gets past pistons in there and routes it back to the reservoir. And that's where we're going to tie on our case drain from our hydraulic motor on the fan, and that it's the small hydraulic line, a 3/8 inch hydraulic line that comes back from that motor. But that fitting down there, that one that is slightly rusty but goes to that crimp fitting on that big line, is our case drain. And you'll need to break that loose on that. It won't be terribly hard to break it loose on that pump. Clean it off first before you break that loose. And then you'll take that fitting off and lift the hose up high quickly, because it's going to be below the fluid level in the tank and it'll start to leak hydraulic oil. But if you lift it up, it won't leak, or won't leak a lot. And then we'll have a run tee that we'll put in place on top of that pump, and then our hose will go back on the side port of that run tee, and then this return line to the reservoir will come back down on the top end of that run tee and tie it all together. So we're just going to add a little T in there and bring our case drain back in with the case drain flow from this pump. All that's just headed back to the reservoir at low pressure. But anyway, that's where we are. I don't know if I can get any better look at it. I'm going to go underneath the exhaust pipe here, and that's that pump. Comes right out of the gearbox here, and it's called a case drain flow from that piston pump. And that's how so we'll put a run tee on the top of it and tee our small line into the side of that run tee through an adapter fitting. I'll show you that in just a minute.